Hello, Riles. In lesson 7.3, we were taking our formula for the future value of a compound interest investment. We could have written it as future value is present value multiplied by 1 plus our compounded interest rate to the exponent, the number of compounding periods. We talked about how, in this case, in 7.2, we were tracking it forward, and that's why we were seeing a positive exponent. If we wanted to isolate for our principal or our present value, we could have written it as a and then dividing both sides by 1 plus I to the exponent n. And we reviewed this year what we learned in grade 9, that divisions can be written as powers with negative exponents. Where we're going to see this over the next couple of days is if we're tracking backwards on a timeline, we want our exponent to be negative. So this formula is a useful one to use when we start talking about present values of annuities in lesson 7.5. Okay. What I wanted to practice doing with you in this video is a couple of questions where we solve for other unknowns. And you can take two approaches to it. You could try solving, we should be able to solve just right in the equation, or we might want to try solving with some numbers put in as well. So let's just try an algebraic one, and then we'll write an example and show you why I don't think you should bother rearranging algebraically. Let's say given a equals p times 1 plus I to the exponent n, let's isolate for I. Maybe we know what our amount and our principal we want to be, and we have all of our frequencies calculated, and we just want to figure out what interest rate we're going to need. Well, just treat this like a onion situation. You're trying to isolate for I. You're going to be undoing these operations in a reverse BEDMAS order. So like the closest thing to the I is the addition of 1. That's the last thing I'm going to undo. The next closest thing to it would be the exponent here. And that means that the furthest thing from it is the principal. So I'm going to divide both sides by the principal, and that'll give me a divided by p equals 1 plus I to the exponent n. You could try doing this faster like we did with trig equations, but if it's your first time dealing with an equation like this, we might want to take things slow. Be careful how you write things here. To undo raising to the exponent n, I will want to take the nth root of the right-hand side. If I do that to maintain equilibrium, I have to take the nth root of the left-hand side, not just the numerator. I'm not just taking the nth root of the numerator on the right-hand side. I am taking the nth root of the denominator of the entire right-hand side. And to make that absolutely clear, use either a gigantic symbol and or brackets to show what your base is on this power. And that would leave me with, I guess I have the nth root of the ratio of a to p is going to be 1 plus I. Well, now we're just one step away here. We subtract 1 from both sides. I'll go over to the side here to save some space. And I'll get I equals the nth root of a divided by p minus 1. And just like how the present value formula is not worth memorizing, you can visualize it from a timeline for lesson 7.5 if you need to. Do not try to memorize this formula. Okay, let's write a word problem question here to help us realize that we don't need to memorize how to rearrange algebraically. We can rearrange numerically on the spot. Well, I think we did one of these in class, but we'll get another one. Let's say what compound, let's say annual, compounded interest rate is required for an investment to, let's say, triple in, I don't know, 7 years. That's a kind of a short period of time, so the interest rate might be pretty high. Now, a question like this would, as always, say, show your work algebraically, or up at the top of our test, it would say level 4 requires a well-communicated solution, so you should not be using trial and error here. Okay. The information that we're given, we don't know what the annual compound interest rate is, don't know what I is. I guess we kind of need to show, it did ask for annual compounded interest rate. I guess we're assuming that this is compounded annually then. And that means that our time and our number of compounds is going to be 7. Sometimes students panic now and say, well, I don't know any of the other numbers, so how can I substitute into this formula here that they've just memorized? There is another number sort of in here. It's the tripling. Now, to get full marks, you're not going to, or if you say, well, let's just make the principal $1 and the amount is going to be $3, that's not going to earn you full marks. Because that assumes that we know what our principal is. Now let's just set our amount to be triple our principal. There's no assumption there. And so our formula, a equals p1 plus I to the exponent n, becomes 3p equals p times 1 plus I to the exponent 7. Now you might say, well, I still don't know what p is, but that's not a problem, because to isolate for I, dividing both sides by p is going to be the first thing that I'm going to do. There is a restriction here. Of course, this isn't going to work if p is equal to 0, because I can't divide by 0. But let's think about the application here. You invest $0. How long is it going to take the value to triple? You could say, well, it's never going to triple. Someone else might say it is tripled, because the triple of $0 is $0. It's a moot point. We're not interested in principles of $0. Okay, now let's stay away from rounding off too soon here. Let's take the 7th root of both sides here, and that'll give me whatever the 7th root of 3 is equals 1 plus I, and then I'll subtract 1 from both sides. So I get that my annual interest rate is going to be the square root, the 7th root of 3 minus 1. And now I can type that into my calculator in a couple of different ways. Except, so most scientific calculators, do I have one on me in my backpack? Excuse me. Distraction music. And we're back. Nope, don't have my scientific calculator on me. Most scientific calculators have an xth root button. It's usually pretty darn close to their square root button. So I wanted to show you that button. I might have it in my math menu. There it is, yeah. Xth root, except I think I need to type in which root I want first. So I want to take the 7th root of 3. So I think I type in 7th root of 3, and then I subtract 1 from that. Let me write this down and then we'll check. 0.16993. Maybe safer than doing that, if I'm using a calculator that I'm not familiar with, is going back and using our Unit 3 skills and saying that we know to get the 7th root, we can use the exponent 1/7. You just might want brackets around that. So let's type that in and see if we get the same answer. 3 to the exponent, 1 divided by 7, minus 1. Yeah. Which is a relatively aggressive, or let's say hopeful, about 17.0%. Okay. Tripling in 3 years, or in 7 years, is pretty fast. Okay. Now, there are a couple of homework questions. A lot of them have been trimmed out, or it's identified where you need Desmos, where we'd be solving an exponential equation that we can't solve using our skills from Unit 3. I think it's a good thing to try those questions and a good thing to learn how to use Desmos. Let's try one of those examples here. Let's do another doubling or tripling question. How long will it take an investment to double at 5% per annum, compounded annually? So this is not a test level question in this course, because we don't have the mathematic tool that we need unless we're using a calculator, and I'll show you, or a computer, and I'll show you why. Once again, we're going to set our amount to be, in this case, 2 times our principal. And we know that our compounded interest rate is 0.05. We're looking for t, though. We're solving for the exponent, which makes this a bit of a challenge. Into the formula, a equals p 1 plus I to the exponent n. We replace our amount with the double of our principal, 0.05 divided by 1. And this n is actually going to be the number t as well because we're working annually. And it looks okay to start off. We divide both sides by p, and we get 2 equals 1.05 to the exponent t. And now we're in trouble as grade 11 students, because I don't know how to write 2 as a power of 1.05. Okay. Before we had access to graphing calculators, I could show you how to do it on the graphing calculator here, but that's even more antiquated than the other approach that we would use. There is a dot matrix version of, not really, well, sort of dot matrix, approximation of the curve y equals 1.05. If I zoom out, you can see that it is an exponential curve. Oh, it's thinking hard. Come on, buddy. There you go. Let's zoom out again. Calculating. Good job. There you go. You can almost see it as a curve, except it's actually, because the resolution is not that great, you can see individual pixels here. But right. The alternative then would have been using trial and error. Get out of here. Okay, substituting in a number, seeing, oh, is that too big or is that too small? Maybe I should do a little bit of that. 1.05 to the exponent, I don't know, maybe 10 years. Nah, that's still not long enough, right? 1.05 to the exponent, 20 years. Well, that's too long. And I record these and I use trial and error. We've got a better tool now. And to answer questions like this, until you learn how to use logarithms and advanced functions, just grab a piece of technology that has Desmos. So I've got the Desmos app ready to go here. This is the equation I'm trying to solve. I'm just going to type in y equals 1.05 to the exponent x, and that should get that curve for me. I want to know when it reaches a height of 2, so I'm going to put in the line y equals 2. There we go. What I like about the phone version of Desmos is that when I'm on the computer and I'm using my mouse wheel to zoom, I can only zoom in and out square like this. But on the phone version of Desmos, I can pinch I can pinch horizontally. How come it's not pinching horizontally? I thought I could pinch horizontally and just change my horizontal and vertical axis. Okay, never mind. Maybe you can figure it out. It's my old chubby fingers that aren't working great. If I click on one of the functions, I should be able to type or tap right on the tap right on the point of intersection here. And let's say from Desmos, copyright and sponsor, we get t is about 14.207 years. Okay. I don't think you should look up how to use logarithms. It's kind of like watching someone on YouTube using a chainsaw and then thinking that you can use a chainsaw. You shouldn't have any questions where you have to use logarithms on our quizzes or tests. Just be patient and wait till advanced functions. And your advanced functions teacher will teach you almost everything that you need to know about logarithms. Okay, try it out.